Okay. So first of all, let us discuss what we mean by factor of safety. Let me see if my pen is connected. Um, I think my pen is connected. Yeah. Okay. So generally, factor of safety in slope stability, as I mentioned, that the main thing that we quantify the slope, the quality of the slope with is factor of safety. Factor of safety is simply the two kinds of definitions for factor of safety. One definition states that factor of safety is equal to the average shear strength of soil over mobilized shear strength. And you know the shear strength from um, previous classes we've seen shear strength is sigma dash tan phi dash. This is the effective where dash means the effective parameters. Similarly, we can write the mobilized shear strength as mobilized shear strength is not the maximum shear strength, as in if we talk about slope, the stress will on this, for example, we have a failure plane. The stress will depend upon the loading that is coming down, and the reaction force will depend upon this loading. If the loading is less than uh, the maximum strength, we say that the shear strength mobilize it's the mobilized shear strength. So we have a mobilized shear strength so your Cm and phi m will be usually lesser than your C at failure and tie at failure, phi at failure, and your factor of safety will be tau over maybe at failure over mobilized shear strength. Okay, so based on this description, we have two kinds of factor of safety. Say that C dash is equivalent to 0. So you will have f of phi is equal to sigma dash tan phi over sigma dash tan phi m, which will be f phi equals tan phi over tan phi mobilized. And if we consider phi equals 0, we have fc equals c dash over c dash mobilized. The factor of safety with respect to cohesion, factor of safety with respect to friction, and this is the actual factor of safety. So if we have f s is equal to c dash plus sigma dash tan phi dash over cm plus sigma dash tan phi M. So if Fc is equivalent to F5, you can write Fc is equivalent to F5. Okay. So this is the concept of factor of safety. Now let's talk about infinite slopes. Factor of safety in infinite slopes. So we will have in infinite slopes, we will always have the face of the slope is parallel to the surface of the failure plane. And if we take a wedge here, it will have W in this direction. Let this angle be beta. Okay. So we see there will be a force on this element in this direction, and there will be a force in this direction, and these will cancel out. So if we take this element alone, this is the force in this element, and if we are taking this as H, and this as L, and let us talk about the forces um, that are acting on this A B surface and BC surface. On AB, uh, let me draw a better diagram. Yes. Excuse me. So there will be a, if we talk about the surface, excuse me. Okay. So on AB, that is a force W. There will be a normal force, under tangential force. The weight of the soil element, the W, will be volume into unit weight, gamma into L into H. The force perpendicular to this, the normal force, will be, this is like beta, W. This will be W cos beta, and the tangential force will be W sin beta. And we calculate, excuse me, uh, this is the stress, we multiply it by area in the normal direction. The area is H cos beta, no, not H cos beta, it's L by cos beta. So the normal force to get the normal stress, to divide by area, W cos beta over L by cos beta. So we get sigma n is equal to W or gamma h cos square beta, and we get tau is equal to gamma h cos beta sin beta. So this is the weight, this is the normal or sigma n, and this is the tau. So we know the reaction of the weight is equal and opposite to this reaction, to the reaction force of due to the tau and sigma. So the reaction force sigma n is basically r cos beta, and tau is basically r sin beta. This is equivalent to gamma h cos square beta, and this is equivalent to gamma h cos beta sin beta. And from this and this goes, this and this goes, excuse me. We know tau, the shear strength, uh, is equivalent to, or tau mobilized is equivalent to C dash plus sigma dash tan phi d, and sigma dash from here, C dash plus gamma h cos square beta tan phi d. This is your mobilized shear strength. while your this is your shear strength at failure, while your mobilized shear strength is this gamma h cos beta sin beta, and you get factor of safety is equal to tau over tau m. Tau at failure is c dash plus sigma dash, that is gamma h cos square beta tan phi, based on Mohr-Coulomb theory, and actually calculated tau m is gamma h cos beta sin beta. Now if we have a cohesionless soil, this just reduces to factor of safety is equivalent to tan phi over tan beta. And this is already covered in class, so I'll not go into detail. So let's then start and solve this question based on your infinite slope analysis. The factor of safety against, we have to calculate the factor of safety against the sliding along the soil and rock interface. We have been given gamma, c dash, phi dash, h, and beta. So we know factor of safety we just saw is equal to c dash plus gamma h tan beta, sorry, cos beta cos square beta tan phi over gamma h cos beta sin beta. This is equivalent to 10 plus 17.8, beta is 15, cos of 15 square tan of 20. Then we have 17.8 into 6, there was a 6 here also, cos 15 sin 15. Let's calculate. Okay. Uh, Sorry, I disconnected my earphones by mistake. I hope I'm audible, else I'll have to start this meeting again. Okay. So this comes out to be uh, something wrong again.